Welcome back to another video tutorial on chapter 17, Understanding the Atom for grade 9s. In this very short video we're going to be looking at the various parts of an atom and describing the charge and location of these subatomic particles that make up an atom, and understanding how to use the periodic table to determine the number of protons, electrons and neutrons an atom has. So first and foremost, let's talk about this diagram here. In many textbooks you'll see the structure of the atom is often drawn like this, where in the center you have two of the three subatomic particles. You'll have here the red ones, often colored red in many textbooks, to demonstrate the location of the protons, and sometimes in green or yellow you have neutrons, and on the outskirts you have these smaller particles known as electrons. Now let's talk a little bit about these three particles. So first and foremost, some important information you need to remember is the location. You must remember the center of an atom is often called the nucleus, and this is where the protons and electrons live. And on the outskirts of the nucleus, in what we call orbitals or shells, is where electrons are located. Now there are a couple of things wrong with this diagram, but it's accepted as a simple 2D model of an atom. But we need to remember atoms are 3D and electrons are not stationary. We don't actually know where electrons are at any given moment, but what we do know as chemists is they exist in these areas around the nucleus, often called orbitals. Now for the purpose of simplicity, these are drawn as lines of where electrons move around, but these obviously do not really exist in real life. These are just to show us how they are, where they are located. In a later lesson, perhaps in chapter 19, you will learn more about orbitals, and you will learn about actually how many different types of orbitals there are and where these electrons are. But let's stick to what we want to talk about today, which is the location and the various information about these particles. So number one, protons and neutrons are located inside the nucleus. Electrons are arranged in shells around the nucleus. Protons have a +1 charge or positive charge, and the electrons have a negative charge. And neutrons have no charge at all. So that's why they're often referred to as neutral subatomic particles. This is really important because one of the rules is that an atom in its entirety will be neutral overall. Why? Because the number of protons it has will be the same number as the number of electrons, and as a result of that, plus and negatives will cancel out. So atoms on their own will have no charge. Later on in this unit you will learn about what happens when an atom will gain or lose electrons. When they do this, they will gain either a positive or negative charge depending on if they are gaining or losing electrons. So on their own as an atom, they are often referred to as neutral. Masses. Protons and neutrons have a mass of 1 each, whereas electrons are so light and insignificant they are often referred to as having no mass. Of course they have to have some type of mass, but the number is so small and minuscule it's often written 0 in many textbooks, or taught as 0 in chemistry. What does this number 1 mean? We'll learn about this later on in another topic, but for now remember protons and neutrons have a mass of 1 each, electrons have a 0 mass. In your class you would have probably now been given a copy of the periodic table, and in the periodic table you'll have the list of all known elements with their symbols. Now you need to remember these symbols are not the start of the name of the word. So for example, here you can see carbon starts with the letter C, and therefore the symbol is C. In some cases this is correct, however in many other cases this is not the same pattern. The reason being is these have been named from various parts of the world, and therefore not all of these words have been in English. So although some of them might look like the fact that carbon begins with a C and here the letter is C, many other elements do not follow this pattern. For example, you will see potassium. In English the letter begins with P, but actually the symbol for potassium is K. Another one, gold, begins with the letter G, but actually the symbol is the letter AU. So remember that these are not specific to English, these are from many other languages around the world, like Latin, Greek, French, and so on and so forth. Now another interesting thing to remember about nuclear notation or symbols of these is some elements have just one letter, whereas some will have two. How can you distinguish between which is an element or which is a compound? Well, first and foremost, if an element has only one symbol or one letter for the symbol, then it will always be capital. If it has two, so for example, cobalt, if you have a look at the periodic table, cobalt has the symbol C and O. Now, sometimes some students get confused with the compound carbon monoxide, which is also CO. They look very similar and it's easy to make a mistake, but the way you differentiate this is by looking at the second letter. If the second letter is a small lowercase, then this indicates that it's one symbol, meaning C and O is stand for cobalt because the O was lowercase. If you have a capital letter C and a capital letter for O, although it looks the same, CO, it's not the same element. I beg your pardon, it's not the compound, it's actually two elements there, which is going to be carbon and oxygen. So that's a side point to remember. Next to every letter on the periodic table or every element, you'll see two numbers. And for example, here carbon has the number 6 and number 12 at the bottom. Important points to remember about these two numbers. Number one, you must never learn these numbers as the top number or the bottom number. The reason being is many other companies who publish periodic tables will often invert them. So some companies will print this number here at the top, some will print it at the bottom, and some will print this at the top and some at the bottom. So it's important to remember what these numbers mean. This number here, the 6, this number is often what we call the atomic number. So remember that word, atomic number. And the large number here is what we call the mass number. Now you might be wondering, why is this 12.0111? In a later video you will learn about something called isotopes, where there are many other forms of carbon, and this is actually an average of these, but that will be left for another lesson. So let's talk about the atomic number 6. What does this 6 mean? This 6 here refers to that one atom of carbon actually consists of 6 protons. 6 protons. Remember this, the atomic number tells us the number of protons. The 12 here tells us the number of neutrons and protons. So if I want to just specifically work out what the number of neutrons are, I will do 12, take away 6, and I'm left with 6. So I know that this carbon atom is made up of 6 protons and 6 neutrons. And that leaves us the number of electrons. Because it's made up of 6 protons, which are positively charged, and we know all atoms in their original form are neutral, therefore this also will have 6 electrons to cancel out. Let's have a look at another example. Let's have a look. So here we have a copy of the periodic table, and you can see there are many elements, they're all color coded, and the reason they color coded is to tell the observer here that these are from different groups or from different categories. So these are all alkali metals, alkaline earth metals, transition metals, these are post-transition metals, non-metals, halogens, and then noble gases. You can see here, actually, interestingly, most of the periodic table here, if we go across from the left to the right, is metals, and we all actually have a small amount of metals. So let's pick another element out. For example, let's have a look at magnesium. So if I write down the symbol for magnesium, I'm going to put myself a piece of paper here. I can see here magnesium has a symbol Mg, and in this case the atomic number is 12, and then at the bottom the mass number is 24. What does this mean? This means that magnesium consists of 12 protons and 12 electrons. And to work out the number of neutrons, I simply do 24 minus 12, okay, which is also 12. And therefore I know this has 12 neutrons. Alright, so this is what makes up this particular atom of magnesium. Now you can see here, if I compare that with carbon that we just did a few minutes ago, I'll write it out again here. Carbon was 6 and 12, and therefore 6 protons, 6 electrons, which was, and then here 12 minus 6, which is 6 neutrons. You can see here that indeed carbon has less subatomic particles inside its atom compared to magnesium, and therefore that means magnesium, the atom, is going to be larger than carbon and therefore heavier. So that's it really, that's as simple as it is there. You can pick out any element on the periodic table here. We'll do another one for clarity. So let's have a look at oxygen. Here we are, oxygen there. Let's write the symbols in. Oxygen has the atomic number of 8 and has a mass number of 16. So if we do the maths, this is made up of 8 protons and 8 electrons, and then last is 16 minus 8 is 16. Therefore, 16 minus 8 is 8. It's also made up of 8 neutrons. Now, it's not always going to be the case where all the three numbers are going to be the same. There are some elements that don't have the same pattern. But we know oxygen, therefore, it has in its nucleus 8 protons, 8 neutrons, and then there are 8 electrons orbiting the atom there. And it's as simple as that. You can pick out any element on the periodic table and you can just use the right numbers here, the mass numbers and the atomic number, to determine how many protons, electrons and neutrons exist in the atom. You are not expected to memorize this. If you did, that would be amazing, but that's not necessary because you will always be given one of these in the exam. As long as you are able to identify the mass number, the atomic number, you should be easy to go. Now, I'll just remind you one more time. Do not learn these numbers as the top number or the bottom number. The atomic number is always a small number, and this is the number of protons. The mass number is always a large number, and this is the number of protons and neutrons. And the number of electrons will be the same as the number of protons for the atomic number. Thanks very much for listening. I hope you found that easy to understand. Any questions, feel free to ask or ask your teacher.